Hello friends, welcome back to my channel. In this video, we shall learn the concept of force from physics, which is related to Gpstr exam 2022, and this concept is given in the syllabus. Okay, so already we have covered up many concepts in physics related to Gpstr exam 2022. Please check the description box, or you can check the playlist of our channel for those videos. Okay, so before moving to the video, I thank all my subscribers for your kind support, and if you are new to the channel, please do subscribe and support us. Okay, come on, moving to the concept of force. Force is that cause which changes the state of a body. So when force is applied on an object, it can bring a change in the size of an object, or it may bring the change in the shape of an object, or it can bring a change in the speed of an object also. In simple terms, to say that force is push or pull of an object, we can say, right? Fine. Usually this definitions and all won't be asked in the exams, I feel so. Let's learn the concept, understand it, and then we'll go to the important points. Then force is a vector quantity. It means it has magnitude as well as direction. Force does not change the mass of a body. Okay, so these are the basics, and we have already learned about F is equal to ma, that is Newton's second law related to force. You can check the previous video for all these examples for Newton's second law. Here in physics, we cannot give a separate concept, like, they are linked one next to the other. Okay, so there will be some relation between the concepts of physics. So let us recall that. And SI unit of force is Newton. Symbol is N. And 1 Newton is equal to 1 kg meter per second square. This is important. Remember the value. 1 Newton is equal to kg meter per second square, or 1 kg meter per second square. That is also right. How do we define 1 Newton force? 1 Newton force is defined as when a force is applied on an object of mass 1 kg to increase the speed of an object by 1 meter per second in 1 second. It is called as 1 Newton force. Imagine you have an object of 1 kg mass, okay, and you are applying few force, okay, we don't know the force. If at all, this force has to be defined as 1 Newton force when this object is moved to 1 meter distance per second, so that this action is performed in 1 second. Okay, and hence you are increasing the speed of an object. It is called as 1 Newton force. Next, on moving to the force of gravity, is defined as it is the force of the earth in which it attracts the objects towards itself. Okay, the earth attracts the objects towards itself by force of gravity. 1 kgf is equal to 10 Newton. This is the relation between kgf and SI unit of force. Next, mainly we divide this force into two categories: contact force and non-contact force. Any changes if we have to bring on the object in size, shape, or speed, there are different methods, and applying the force is the basic, right? When you apply the force, the object is displaced, object is deformed, it takes a different shape. So whether we really touch the object and we apply the force, or without touching the object we apply the force, that says about the contact and non-contact force. So when force is applied on an object with physical interaction is called as contact force. Example of contact force are normal reaction force, muscular force, frictional force, tensional force, spring force, etc. Moving about normal reaction force. Imagine there is an object on a table. Okay. So this object is in physical contact with the table. It is touching the table. It is on the table, right? So now there are two forces acting on it. One is the object experiences a force. It exerts a force, downward force. The object exerts a downward force, that is W is equal to mg, and the table exerts a normal reaction force upward, that is equal to R, and normal force is always perpendicular to the surface that an object is on. So this is the object where it is placed, and normal force is perpendicular to that object, usually like this it is. So this is of, hence the objects are in physical contact, and normal reaction force is an example of contact force. Okay. Learning about muscular force, we push the object by our hands. We use our muscles to do the work, right? Pushing a car, pushing a table, pulling a chair, or all this, opening the door, closing the gate. Many exercise we do all this actions using our muscles. So these are the example of muscular force, and muscular force is a contact force. In the exam, they may give few type of force, and I ask you to identify, choose the contact force among all this given. So they can ask like this. Okay. Next, about frictional force. So frictional force is the force between the two objects. Without friction, for simple example, we are unable to walk on the ground. Means the frictional force keeps us a steady movement to walk on the ground. If the floor is of slippery, if it is very smooth, soft floor, there is less friction between the foot of our leg and the floor. Hence we fall. So frictional force is necessary, and frictional force is a contact force. There is a contact between the object, the person one who is walking, and the floor. We can say that. Okay. Okay. Moving to tensional force. So you can observe here, there is an object hanging with the help of a support. So this is the rigid object. Object is hanging here, and this object experiences a force of tension which is upward. You see, tensional force is like this. The object is experiencing a tensional force. So this is in contact with the object is in contact with the rigid support, the string, and along with the rigid support. This is an example of contact force. Spring force. So look at this diagram. Here set of springs are hanging with the help of a support. So this spring force is also an example of contact force. Okay. So any object which is come in contact with the relative object here, so those type of force which is experiencing a force is called as contact force. On moving to non-contact force, this force is defined as the force which acts from distance. Okay. So easily you can understand by looking at these examples. Magnetic force is a non-contact force, electrostatic force, gravitational force. Actually, in case of a magnetic force, magnet attracts magnetic substances. In the previous video, while I was explaining about magnetism, there was a small concept about magnetic substances, and by editing mistake, I couldn't explain. I explained there, but it was missing in that part. So I just explained here. So for magnetic substances, what are magnetic substances? Substances which are attracted by magnet are called as magnetic substances. For example, iron particles. Iron is attracted by magnet, hence iron is a magnetic substance. Non-magnetic substance, example you can take plastic or paper, which will not be attracted by magnet. Those are non-magnetic substances. Okay, come, let's look about the non-contact force in magnetic force. So magnet attract the magnetic materials towards itself. Actually, you no need to bring the magnet exactly on this material to touch the material. As you bring the magnet little bit closer to the magnetic substance only, substances start attracted towards the magnet. So there exists no physical contact actually. The force itself exerts, it's present there. So this is an example of non-contact force. Look at this diagram, you see many objects are attracted towards the magnet. These are magnetic substances, maybe pin, steel, a small nail and all. These are magnetic substances. Actually there exists no physical contact, but they brought closer to the magnet. It is because of non-contact force. We name this as non-contact force. Okay, this is because of attraction of magnet. Magnet's ability to attract the magnetic substances towards it. Example of electrostatic force. Take a balloon and fill the balloon with air and rub the balloon with the palm. Hence balloon gets negatively charged, and bring the balloon near the small pieces of paper. Okay, balloon attracts the few pieces of paper. The pieces of paper which are attracted towards the balloon, they are positive, hence they are getting attracted towards the negative. Some piece of paper which are repelled by the balloon will be having same charge negative, it will be repelled. Actually in this case the balloon is not in physical contact with the piece of paper here. As soon as you bring it near that area of the piece of paper only, it start attracting. So this is an example of non-contact force. Gravitational force is also an example of non-contact force. So we see the earth is attracted by the sun. It revolves around the sun. There exists a force between the sun and the earth. The same with the other planets also. Hence they revolve around the sun. So that force, the pulling, gravity we call it, is the gravitational force between the earth and the moon also we can say that. There exists no physical contact between this earth and the moon, but still there is a kind of force which is acting, that is gravitational force between the moon and the earth, and it is example of non-contact force. Next we shall move to another important concept in physics, that is work. So work is said to be done only when the force applied on a body makes the body move. So you need to apply the force on an object. If the object moves only, work is said to be done. For example, you try to push a wall. Okay, if the wall moves, then they are said to be work is done according to physics. If this wall does not move, even though how much ever force you apply also, there exists no work, means no work is done. So work done can be expressed the product of, that means multiplication of magnitude of force and the distance moved by the object in the direction of the force applied. If you are applying the force in this direction, object also has to move in the same direction, then the work is said to be done in general form. Okay, so W is equal to F into S, that is force into displacement. And find out whether this is vector quantity or scalar quantity. Obviously we speak about direction, so it's a vector quantity. Work is a vector quantity. SI unit of work is joule or joule. Some pronounce as joule, no problem. It is from the name of a scientist. So the first letter, when we write the full word joule, should be small letter as unit, but symbol should be capital letter J. 1 joule is equal to 1 Newton into 1 meter. You see, how do we get this 1 Newton into 1 meter? SI unit of force is Newton. SI unit of displacement is meter, that is for length, so Newton meter. So 1 joule is equal to 1 Newton into 1 meter. How do we define 1 joule? 1 joule of work is said to be done when force of 1 Newton displaces a body through a distance of 1 meter in its own direction. Then the work is called as 1 joule. Suppose if there is no displacement, if the displacement is 0, work is also 0. We can also move to this work done by the force of gravity. On learning about that, it is expressed by the formula W is equal to mgh. Okay, this is somewhat related to potential energy formula, right? Same thing here. So work done by the force of gravity W is equal to mgh if an object moves downward. Okay, suppose if the object moves upward, then it is W is equal to minus mgh, and work is a vector quantity, we know. There are few more units, that is bigger units of work: kilojoule, megajoule, gigajoule also we go for next. Find out how much is 1 gigajoule is. Okay, 1 kilojoule is equal to 10 to the power of minus 3 joule. 1 megajoule is equal to 10 to the power of 6 joule. So usually this and all may not be asked, but just to know few more extra additional points. Okay, it is not necessary that always the force causes the displacement of the body in the same direction. Some circumstances, some cases, the force displaces the body in the direction other than the direction of the force. Suppose you are applying the force in this direction, the object could be moved the other direction also. Okay, so in that case there are two components we can. If it is in case of slope, if the object is moved like this way, okay, in this direction, how do we find out that? There are two methods to find out. Okay, first one, by finding the component of displacement, S value of the body in the direction of the force. Remember, first method is to find the component of displacement in the direction of the force. Second method is by finding the component of force in the direction of the displacement. Okay, these are the two methods usually. First about displacement and second about the force. The general formula to express component of work is F into S cos theta. Okay, we can consider an example of work done. In this cases, quickly we can check it out with all these values of different values of theta. Suppose if theta is equal to 0, there is no angle of elevation here. So if theta is equal to 0, cos 0 is equal to 1, W is equal to F into S. So this case work done is positive. For example, an object falls, a ball which falls freely from some distance, some height h. The mass of the object is m. It is pulled by the gravity g, and from some height h it is falling. So work done is equal to W is equal to m into g into h. There exists no theta value here, it just directly falls. So that is the work done. The direction of the motion or the displacement will be downward like this. Okay, another example we can say that if a body moves in the circular path, exactly the circular path, then under some influence of some force it has to move. On completing one complete round, the displacement is 0. So according to physics, the work done is 0. Okay, so in that case work done is 0. We will check out that in the second case here. Even though it comes under the second case, if theta is equal to 90 degree, we get work done is 0. But here also, in the first case only, if there is no angle actually, if it is moves in the circular path, a person starts at one place and he moves in a circular path, he reaches back the same place. So what will be the work done? Work done is 0. So I used to tell my students these examples. Take an auto in one place, exactly take a circular form and then come back to the same place. You can tell the auto driver, now work done is 0. I won't pay the money for you. You have not done any work. Let us check the reaction of those that person I was telling. Then they were telling, ma'am, next time we won't reach the class. It will be you will mark absent for us. Okay, so according to physics only, in this case, work done is 0. Next, if theta is equal to 90 degree, then cos 90 is equal to 0. So work done is equal to 0. So when you multiply 0 into F into S, 0. So work done is 0. If theta is 90 degree, work done is 0. Okay. So we can given as a example for this theta is equal to 90 degree. In case of a person walks on the horizontal ground, he carries a load on his head. Means like this, he is walking on the ground, he carries the load. Okay, now the displacement, he displaces the object which is on this head. This displacement of the load is normal to the direction of the force of gravity here. So which is vertically downward, in this case 90 degree, hence the work done is 0. In this case there is no work is done against the force of gravity. Okay, he does some work against the force of friction, that is different, but in this case the work done against the force of gravity is 0. Next, on moving to the third condition, when theta is equal to 180 degree, cos 180 is equal to -1. So minus 1 into F into S gives us minus F into S. Hence the work done is said to be negative. So if at all it is asked in the exam, they may ask you for these points. Okay, giving the different angles of theta, find out the work done by the person. So we can give an example of this theta is equal to 180 degree. When a body moves on the surface, the force of friction between the body and the surface, if this is the floor and an object is moving on this, the force of friction between the body and the surface in the direction opposite to the motion of the body. Object is moving in this direction. So this angle is 180 degree between the directions of the force, and hence the frictional force, the work done by the force of friction here is negative. Okay, clear. So don't get confused with all this in few examples and all. If you get more sources, you can refer. Otherwise, you remember these angles. Okay. Okay. So we'll wind up here. We'll continue the other concept in the next video. So thank you for watching. Thank you for your support. If you like this video, give a thumbs up so that it will encourage us, so that we will come to know that you really like our class. Okay. Thank you for your valuable feedbacks. Few have asked to explain this concepts in Kannada. I'm sorry, like my Kannada pronunciation won't be that good, I say. So we'll continue that in English. Okay, I'll try to go a little more slow in order to make you to understand. Okay, thank you so much. Thank you for watching.